Okay, so now we're going to get into the cool part of NMR, and I just want to take a couple minutes to describe the characteristics of an NMR spectrum. So there are four things we're going to get. So it's going to look something like this, okay? They oftentimes won't be quite this pretty. We're going to get something like this, and there are four things we're going to look at, and it's so powerful. First of all, we're going to look at the number of signals, and we're going to say that the number of signals here is 3, okay? 1, 2, 3. Okay, number of signals, because this is going to tell us the number of unique hydrogen environments. All right, unique hydrogen environments. Then we're going to look at the signal location, and that is, this one's about what, 1.3, 1.3. This one's about what, 2.6. Can you see that? Can you see what I'm looking at here? 1 point, just a second here, 3. This is about 2.6, okay? And this is about 7.2, 7.2. And you're going to be amazed at how much information this is going to give us. I could just about tell you what this was. Well, I could tell you exactly what this is just by looking at this graph. And it's because it's so powerful. This, I'm not even going to tell you because it's going to seem like I'm just beating my chest or something. But it's amazing how powerful this is. So 7.2, very characteristic. We'll have a table. We don't have to memorize these numbers. 7.2, we know exactly what that is because there's something very characteristic of 6.5 to 8, or 6 to 8.5, 6 to 8.5. Okay? So anyways, the signal location is the second thing, right? The number, signal location, the intensity, that is the area under the signal. So what's going to happen, typically these will be integrated for you, and there will be like a number 5 next to that, and a number 2 next to that, and a number 3 next to that. So can you see that this curve here has a bigger area than this 3 does? Because it's not higher, right, but it's just wider. There's more hydrogens. This represents 5 hydrogens. 5 hydrogens. This represents 2 hydrogens. And I just happen to recognize this signal pattern. That's how I know that. This is 2 hydrogens, number of hydrogens, and this is 3 hydrogens, okay? And so that number will be given to you, 5, 2, and 3. You wouldn't be expected to integrate that with your eyeballs, okay? The signal intensity, that's the area under the curve, okay? This corresponds to the number of hydrogens. This corresponds to the kind of hydrogens, okay? And signal shape, the splitting pattern. This corresponds to the surroundings. Okay, and we'll have a separate video on each of these 4 things. The number, the signal location, signal intensity, and the signal shape. All right, hold on to your hats. We got some neat things coming.